Today we're going to be exploring the science behind electrochemistry. Essentially, all this demo really is setting up an electrolytic cell and allowing electrolysis to take place. But what exactly is electrolysis, and how does it work? Electrolysis is the transferring of electrons through a substance to effect a chemical change. The transferring of electrons is done by setting up an electrochemical cell. The electrochemical cell contains a reaction called a redox reaction. A redox reaction is where one-half reaction loses electrons and one-half reaction gains electrons. In an electrolytic cell, both the anode and cathode are placed in the same electrolyte solution containing both positive and negative ions. The power or voltage of the cell comes from a power supply such as a battery. However, in an electrolytic cell, the anode and cathode switch identities and the anode is now positive and the cathode is negative. The cathode continuously supplies electrons to the anode. Also note the bubbles forming around the pink color. Now let's figure out what's actually going on here. First, let's look at the oxidation numbers of the two half reactions. One reaction is as follows: 2H2O plus 2 electrons yields hydrogen gas and 2 OH-. In a molecule, oxygen has a -2 oxidation number, so in order to get a neutral molecule, hydrogen must be +1. The same oxidation numbers apply for hydroxide, as there is only one hydrogen, giving the molecule a negative charge. However, a lone element always has an oxidation number of 0. Since hydrogen went from a +1 oxidation number to 0, we know that water is reduced, so this reaction is happening at the cathode. The second half reaction is Fe solid yields Fe plus 2 aqueous plus 2 electrons. Again, lone elements have an oxidation number of 0, and ions have an oxidation number equal to their charge, meaning Fe plus 2 has an oxidation number of +2, and iron has an oxidation number of 0. Now we know that iron is oxidized as the oxidation number increased, so this reaction is happening at the anode. At the cathode, electrons from the iron nail cause the reduction of water like we saw earlier. 2H2O plus 2 electrons yields hydrogen gas plus 2 OH-. The phenolphthalein in the electrolyte solution then reacts with the OH- to form the pink color. At the anode, oxidation of the other nail then produces electrons which enter the circuit. The Fe plus 2 then reacts with the potassium ferrocyanide to produce the blue complex. I hope you enjoyed taking a small look into the world of electrochemistry.